Good afternoon, students. So today we solve problems on ordinary differential equation. So again here the problem is d square minus 2d, solve d square minus 2d plus 5 y equal to sin 3x. Okay, so this is the given problem. Now we write the auxiliary equation. So that is we replace capital D by m. So which gives m square minus 2m plus 5 equal to 0. Then solving this equation we get two roots because it's a quadratic equation and we get two roots. So those are m is equal to 1 plus or minus 2i. So here the roots are complex. Okay, so the roots are complex, that is m is equal to 1 plus or minus 2i. So complex in the means if it is in the form of a plus ib, then it is complex. So, okay, so here m is equal to 1 plus or minus 2i, so it is complex. So now for complex roots we find the general solution as e raised to alpha x. So here alpha means 1, beta means 2. So complementary function or general solution is equal to e raised to alpha x, alpha is 1, e raised to alpha x into bracket c1 cos beta x, so beta is 2, c1 cos 2x plus c2 sin beta x, again beta is 2, c2 sin 2x, right. So this is the general solution. Okay, so now we write the particular integral. So your particular integral is 1 divided by d square minus 2d plus 5 sin 3x. So as it is a function f of x is a sin ax or sin 3x, so here the rule is just replace d square by minus a square. So here a is 3 because x coefficient in the sine function, that is a. So a is 3, a square means 9, minus a square means minus 9. So d square is replaced by minus a square, so it is minus 9 minus, write d as it is minus 2d, then plus 5 as it is sin 3x. Then simplify this, which gives minus 2d, then minus 9 plus 5 is equal to minus 4, then taking minus 2 common we will get d plus 2, minus 2 into d plus 2 sin 3x, minus 1 by 2, that is one divided by minus 2 into d plus 2 sin 3x. Now in this case again we should operate this on sin 3x, but here we need d square, but there is no d square term, so we have to what we do, we rationalize this, or we multiply and divide by d minus 2, so you multiply first by d minus 2, so in the numerator d minus 2 will come. Next in the denominator already d plus 2 is there, when you multiply this with d minus 2 it gives d square minus 4. So therefore this is equal to minus 1 by 2 into d minus 2 into 1 divided by d square minus 4 sin 3x. So now this is to be operated on sin 3x. Now write this one as it is, minus 1 by 2 d minus 2 into bracket, then 1 divided by, again we apply sine rule. So sine rule means here you have to replace by d square by minus a square, so minus a square means minus 9 minus 4 sin 3x. or 1 divided by this minus 9 minus 4, it is minus 13. Then this minus 13 and this 2, they are multiplied each other, and here it is also minus, it is also minus, so minus into minus becomes plus. So 1 divided by 26 into this d minus 2 as it is, then sine 3x. Now this 1 by 26 as it is, now this is to be operated on against sine 3x. So d sine 3x. So d means differentiation. So d sine 3x means differentiation of sine 3x. So which is 3 cos 3x. Then minus 2 into sine 3x, 2 sine 3x. Okay, so this is the particular integral. Therefore, the solution is y into general solution e raised to x into c1 cos 2x plus c2 sin 2x into bracket plus 1 by 26 into, this is a particular integral, 3 cos 3x minus 2 sin 3x. So therefore, this is the solution of the given problem. Okay, now this is about when f of x is sin 3x. Next, we have another problem where f of x is an algebraic function. So here d square y by dx square minus y equal to 2 plus 5x. This we have to solve. D square y by dx square minus y equal to 2 plus 5x. Okay, so here the given differential equation can be written as d square minus 1 into y equal to 2 plus 5x. Okay, so which gives, so here this problem is d square y by dx square minus y is equal to 2 plus 5x. Now this can be written as d square minus 1 into y equal to 2 plus 5x. Now the auxiliary equation is m square minus 1 equal to 0. Now split this we can write as m minus 1 into m plus 1 equal to 0. That means m is equal to plus 1 and minus 1. So the roots are real and distinct, they are indistinct. So therefore the solution is c1 e raised to x plus c2 e raised to minus x. Next particular integral is particular integral is 1 divided by d square minus 1 into 2 plus 5x. Now in this case, we bring this term in, then take minus common. We take minus common from this term. So when you take minus common, then what happened? It becomes 1 divided by minus of 1 minus d square. So now therefore minus, now this is 1 minus d square. Now bring this 1 minus d square in the numerator, then it becomes 1 minus d square raised to the power minus 1. Okay, so when you bring the denominator term in the numerator, then its power becomes negative. So therefore this becomes 1 minus d square raised to minus 1, 2 plus 5x. Now this is again expanded using 1 minus x whole raised to minus 1 formula. Okay, using 1 minus x whole raised to minus 1 formula. So that is 1 plus x square plus x cube and so on. So therefore here 1 minus as it is, now expanding this term using the formula 1 minus x whole raised to minus 1, which use 1 plus d square plus d raised to 4 plus dash 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 2 plus 5x. Now we operate one by one on this equation. Okay, so first one is what? Minus as it is. So 1 into 2 plus 5x, it is 2 plus 5x. Now d square of 2 plus 5x, d square of 2 plus 5x. What is d square of 2 plus 5x? Now one thing you should remember, that while operating any operator, while operating any differential operator on any function, see that if the order of the differentiation is more than the power of x, then that operation becomes 0. Now see here, this is d square Now we have to operate d square on this 2 plus 5x. Now this d square, it is of order 2. Now this x is having power 1. Similarly here 2 is there, 2 can be written as 2 into 1, and again 1 can be written as x to the power 0. So in both the cases, this order of this differentiation 2 is more than power of x. So automatically its differentiation is 0. So therefore here d square of 2 plus 5x becomes 0. D square of 2 plus 5x becomes 0. Similarly, when you take d raised to 4, it is again order of this differential operator d4 is more than the power of x here. Power of x is 1, so 4 is more than 1. So therefore d raised to 4 of 2 plus 5x is also 0. Okay, so therefore what you should do, if the power of derivative is more than the power of x, then neglect that term. Neglect that term, because that term is going to be 0. So therefore we write this as minus 2 of 5 plus x. So therefore particular integral is minus 2 of 5 plus x, and the solution is, we write as y is equal to general solution. Already we found the general solution, that is c1 e raised to x plus c2 e raised to minus x, minus particular integral minus 2 minus 5x. So this is a solution of the given problem. Next we have another problem. Solve d cube minus d square minus 6d into y equal to 1 plus x square. Now again write the auxiliary equation, m cube minus m square minus 6m equal to 0. In all the terms m is common, take m common, so we will get m into m square minus m minus 6 equal to 0. Then again factorize this m square minus m minus 6, which gives m minus 3 into m plus 2. Okay, so therefore m into m minus 3 into m plus 2 equal to 0. Okay, so m into m minus 3 into m plus 2 equal to 0 you will get. So therefore the roots are m is equal to 0, 3 and minus 2. Therefore the complementary function or the general solution is c1 plus c2 e raised to 3x plus c3 e raised to minus 2x. Now we find the particular integral. So particular integral is 1 divided by d cube minus d square minus 6d into 1 plus x square. Again here d common, take d common, and you will get d square minus d minus 6 into 1 plus x square. Now see here, now 1 by d as it is. Now in this case we have to bring this in the form of 1 plus d form, 1 plus x form. So here what we do, we take minus 6 common. We take minus 6 common. So that minus 6 is multiplied with this d. So it gives 1 divided by minus 6d. 1 divided by, when you take this minus 6 common from this, you will get this term as 1 minus d square minus d divided by 6 into 1 plus x square, or minus 1 by 6d into bracket. Now bring this term in the numerator. This gives 1 minus of d square minus d minus divided by 6 raised to minus 1 into 1 plus x square. Okay. Plus x square. Now this 1 minus 1 by 6d as it is. Now again here applying 1 minus x whole raised to minus 1 formula, you will get 1 plus d square minus d by 6 plus d square minus d whole square by 36, and so on, dash dash dash, into 1 plus x square, or which is equal to minus 1 divided by 6d into, now operating this term 1 by 1 on this, so 1 into 1 plus x square, it gives 1 plus x square. Okay, 1 plus x square. Then 7d square 7d square by 36. So it's equal to, so d square of x square, differentiation of d square of x square is 2 times differentiation. So one time if you differentiate this, you will get 2x. Another time when you differentiate, it gives 2. So 2 into 7, 14. 14 by 36. 14 by 36. Or if you divide 14 by 36 by 2, then it gives 7 by 18. So 1 plus x square plus 7 by 18 minus, now d of 1 plus x square, so it is equal to 2x by 6. So 2 1s are 2 3s are minus x by 3. Now minus 1 by 6d into this gives x square, simplifying this term, x square minus x by 3 plus 25 by 18. Now just keep this minus 1 by 6 as it is. Now 1 by d means we have to integration. D means differentiation, 1 by d means integration. So 1 by d of this is equal to integrate this one, which gives x cube by 3 minus x square by 6 and 25 by 18x. So this is the particular integral. This is the particular integral. Okay, so therefore the general solution, therefore the total solution is y is equal to general solution. General solution we already obtained, then plus particular integral. This is the particular integral, this is the particular integral. So therefore this is the total solution of the given differential equation. Okay, next we go to the next problem. D square y by dx square plus 3 dy by dx plus 2y equal to e raised to 2x sin x. Now this is we write this equation as d square plus 3d plus 2 into y equal to e raised to 2x sin x. Now we write the auxiliary equation as m square plus 3m plus 2 equal to 0. M square plus 3m plus 2 equal to 0, or m plus 1 into m plus 2 equal to 0. The roots are minus 1 and minus 2. So therefore complementary function or general solution is c1 e raised to minus x plus c2 e raised to minus 2x. And similarly we find the particular integral. Okay, we find the particular integral 1 divided by d square plus 3d plus 2 e raised to 2x sin x. Now this is of the form, the third rule, that is it is of the form 1 divided by f of d e raised to ax into sin ax. So or e raised to ax into v. So where v is a function of x. Okay, so we have to apply the third rule, that is when when f of x is e raised to ax into v. So in this case what we do, we take e raised to 2x common, and here we replace d by d plus a. So take e raised to 2x common and replace d by d plus a. So a means here it is 2, coefficient of x in e raised to ax, it is 2. So I take e raised to 2x common and 1 divided by, here d is replaced by d plus 2. So d plus 2 whole square plus 3 into d plus 2 plus 2, then write remaining function sin x as it is. Now simplify this, expand this using a plus b whole square and simplify. You will get e raised to 2x 1 divided by d square plus 7d plus 2 into sin x. Now this is a sine function. When f of x is equal to sin x, then we have to apply that rule. So e raised to 2x as it is. Just replace d square by minus a square. So here a is x coefficient, that is 1, which gives e raised to 2x 1 divided by minus 1 whole square plus 7d plus 12 sin x. Now simplify this, which gives e raised to 2x 1 divided by 7d plus 12 minus 1, it is 11 sin x, or e raised to 2x, okay, and we multiply and divide by 7d minus 11, so which gives 7d minus 11 divided by 49d square minus 121 sin x, okay. Divide and multiply by 7d minus 11, it should be minus, okay. By mistaken it has given plus, so make it as minus 7d minus 11 divided by 49d square minus 121, okay. So using a plus b into a minus b, a square minus b square, so divide and multiply by 7d minus 11, so when this is multiplied by 7d minus 11, this gives 7d minus 11 whole divided by, when this is multiplied with 7d minus 11 and a plus b into a minus b formula, 49d square minus 121 sin x, or e raised to 2x, this is 7d plus 11 into 1 divided by, now again we apply the sine rule, so here d square is replaced by minus a square, so 1 divided by 49 into minus 1 minus 121 sin x, or e raised to 2x divided by 170 into 70 plus 11, or 1 divided by, this is 49 minus 1, the 150, so y minus 170, then 70 plus 11 into sin x. Okay, so that is, we have to operate this on this function. So 7d sin x, so it means 7 cos x minus 7 plus 11 sin x, sorry, minus 11 sin x, so this should not come, okay, it will not come, so only e raised to 2x by minus 170 into 7 cos x minus 11 sin x, so this will not come up because we operate this on this equation, we operate this one, so on this term, so means this this will not come, only this is 7 cos x minus 11 sin x. So therefore the solution is y is equal to general solution plus particular integral. So this is the solution of the given problem. Okay, so with this I conclude this class and continue in the next class. Thank you.